How's it going, everyone? Welcome, Julier Gonzalez here. Today, let's take a look now at the number primitive, which is one of the atomic or basic tools, aka or primitive, in the language, which is one of the pillar of JavaScript, right? So JavaScript is made of three pillars, right? The ECMAScript spec, you can read of that, where you have now the type system, the scope system, and then the object systems or objects oriented, right? Now, this is one of the pillar, and when you, or I will say one of the models of JavaScript, of how now the anatomy of JavaScript synchronous, but when it comes to asynchronous nature, we also have another anatomy, right? And this is host dependent. So as a way to handle this concurring task, which is this task that overlaps at a time, now we have here callbacks, thunks, as well as promise. How can we look at promise? What is a promise? What is the nature of the promise, and where promise came from, and what are the things that allow us to do with promise? So in other words, is how can we now think about promise? What is the mental model of promise? That is not only is being able to describe this asynchronous task or chain asynchronous task, but also to describe is the data flow of that, right? So with that, we also look at other concepts, for example, like generators, which give us you the ability to pause and execute the pause and resume the execution of a function, all right? Which is something that we can use to recreate our own asynchronous nature. In other words, the async and await syntax that looks like that you are writing JavaScript in this synchronous fashion, right? One after the other. But the reality is that using generators, we can recreate is this execution. So by stopping the execution, pass control to other instructions, and then once that is done, return or resume the execution of that function. This is very, very interesting. I think this is the next senior interview question, absolutely, because you must know how the things work and what it does, yada, yada, yada. Also another concept when dealing with eventual values, which that's the whole idea of promise, dealing with a single eventual value. But when it comes to series of eventual values, we have now is observables. This series of strings of data that will happen at some point in the future. So we can now sync to that or connect to an event emitter that any time that an event passes through that, we can apply some sort of transformations. So anytime that a data pass through that, we can apply some sort of transformation and distribute that in our system. Now, because this still is a proposal, we right now have a library called RxJS as a way to describe observables, how you can work with them. So for example, is the observables, whether it's primitive or with other complex data, so like promise or generators or even observables, an array. So the idea of this is to explore this particular way of handling concurrency. And yet there is now another paradigm which is known as CSP, communication sequential communication sequential, wow, communication sequential processes. Okay, communicating sequential processes, which is something that language like Go have implemented that. And this is now splitting the communication via channels. So again, this might go beyond the scope of what we really care in today's video, in today's discussion, but it is important to, at some point later on in the course, we're gonna see that. But now that we know is this two part of the anatomy in JavaScript. It is synchronous nature as asynchronous nature, and I know of the asynchronous nature up to a certain point, but then I want to focus my attention is on the synchronous nature, which is this pillar, three pillars: type system, scope, and the objects orientated, where the idea is to look at that particular book, this source, the Node.js, and therefore we can understand first is what is this type systems, the primitive, the object, the abstract operations that happen here, or in other words, the behaviors that happen here, and also is behaviors like equality and coercion, right? So coercion and equality, and of course the type system. So to do that, first we look at the primitive, to describe with the primitive, well, the undefined, null, symbol, a boolean, a number, a string, and last but not least is big int. So we have right now 7 primitives, all right, and objects. So object is not a primitive. Object is a special type of values. So also with describing is these first two, the nullish values, the null and undefined, by walking through the possible values that we can have, or the kind of emptiness that exists, which is undefined, uninitialized, and undeclared, right? And what does it mean? And the several operators that we can use with this null, such as nullish coalescing, which is double question mark, useful for passing out the default values. The other is optional chaining, or the coalescing, let me put it here, the nullish condition, as a way to say, hey, check the record, or check the value of the left for nullish values, all right, before property access, all right. This might be something that you want, all right. But again, the idea of this is improve the readability of your code. Try to avoid this. Be descriptive of what you are doing, which is one of the philosophy of also this particular course, all right, especially with coercion and equality. It's like it is important for you to be clear about what this piece of code is doing, and therefore you can move on. Okay, so not only for yourself, but also for other developers, or even your future self. Okay, where your code must describe is not only what it does or how it does, but the comment must say why you do that. Now, good. Also, the other primitive we look was the boolean. All right. Also, I think I want to make a quick pause here with the distinct value. because you're gonna pass now, if you're gonna define now default values at the parameter levels, unfortunately, functions in JavaScript, they're gonna allow you to pass now null values. All right. So to prevent these behaviors, you can use is now the nullish collisions to check. Hey, if you receive now a null value, this is the value that we need to. Again, this is part of the nuance of working with JavaScript, right? So that being said, we also look at the Boolean values, true or false, and how you can flip from one to another, or toggling from one to another using this question mark. Then we get into a very interesting and barely known topic for a lot of developers, and that is the string and the string nation. All right, and also the number. We're going to focus today is on the numbers only, but I want to make a quick recap here of how do we get here, which is with string. Now with string, we have this particularly representation, okay, where you can use a single quotes or double quotes to represent is also a string, as well as the template string by using the backticks for that. Now, once you do this, it is important to understand that even if you have heard of the UTF-16 or 8 or 32, and you think that this is all that you need to know, you are far from reality. Why is that? Because this representation, if you have seen a particular emoji that give you the length of 2 or 4 or even 11, and if you don't know the answer, let me now help you here. So, because these strings are represented using this Unicode, all right? Unlike ASCII, this which use is now 7 characters, 7 bits, sorry, to represent now a character, which is 128 characters, only for the English alphabet. That's one of the reasons why you are never going to be see is as the letter ñ in Spanish, or any other special characters in other languages. All right, because especially in domains, because the using is now that representation, right? So in your URL or in your domain, you will never see any domain that start, for example, with N. Including that'll be is now. That's a good question. Is there any domain out there with that include these are called internationalization domains, which allow non-ASCII characters, right? Mm-hmm. Jalisco. Sierra del Tigre. I don't know what is this. Mexico? Of course. No, lol. This is California. What? What? Okay. Guanajuato. Okay. Mazamitla, Jalisco, Mexico. It's interesting that it points me to the Google building. Anyway. Yeah, anyway. E.S. Martinez Montañez. Or this one. Come on. I know. Exactly. But as you can see, it is possible. You know? As you can see, it is possible. It is possible to have that. Deputación da Coruña. Indispensables. David Viña. So you can now domains like how they work. When you register a domain with N, it converts to Punicode format. For example, Español.com becomes XN Español server fault or server overstuck. Can I add a special character N in my domain on Heroku? This conversion uses ASCII character to represent the special characters, like Mr. Señor Tacos. Like Mr. Señor Tacos. Supported extensions. Domains that allow N and other special characters include okay, and how users see them. When someone types a domain with N in the browser, mother browser automatically convert it to the preferred format and display correctly. Modern browsers like Firefox, Internet Explorer natively use IDN domains. Natively support IDN international domain. International domain name. Alright. International domain name is not popular because it's definitely not popular because what popular is the ASCII sets, the English alphabet. Alright? Of course, if you go to Japanese and other Japanese or Chinese domains, you're gonna see that. Alright? They're gonna use their own language. But from the West, or in the West, we can now use these special domains, right? So Unicode per se doesn't use that, all right? But the thing here is they work by converting to Punicode format. Punicode. That's interesting. Punicode. International deconverted. URL encoder or Punicode. So for example, hey, Nyandu. Minyandu.com, right? For example, it translated into Punicode. The tool used IDN NA, International Domain Name, 2008 standard, but with Unicode TR-46 compatible processing. Therefore, some conflicted characters are encoded using the old IDN 23 for that. So what is Unicode? It's a special encoding used to convert a Unicode character to ASCII, which is a smaller restricted character set. Unicode is used to encode international domains D. This is quite interesting. This is a very interesting, very, very interesting. So you might wonder, okay, I love about this. I love about this segue. It's a very interesting segue. So, because, okay, this is a very interesting segue. All right, because we talk about is the length of that. Okay, because we talk about is the length of that. Exactly. There is another question. Can we use n in our domain? Can we use n in our domain? In our domain name? Yes, we can, but we need to enable, okay? But we need to enable this, the IDN. But we can, but we need to enable the IDN NA. What does it mean this? All right, is the international domain name. Is the international domain name, which use a very esoteric character set, and I say esoteric because character set, okay, which use a very esoteric, which uses a very esoteric character set called Unicode. Holy moly, it's a very esoteric, bro. It's a very esoteric, a very esoteric, bro. It's a very esoteric, bro. It's a very esoteric Unicode, bro. Very esoteric, bro. He's a very esoteric man. He's a very esoteric man. He's a very esoteric man called Unicode, right? Called Unicode. This allows us to translate Unicode into ASCII. How does it do that? It tries to use a combination of ASCII characters to represent that Unicode, All right. And if you want to know more about this, you can take a look at what is Unicode. I just want to show that this is actually possible with this particular domain. So for example, check out this domain, okay, like so, as it is. So despite that I'm copying here, and look at how that it copy, and I want to exactly look at how that it copy. All right, so it copied me here is with this ASCII characters. Okay, it has now a particular way of doing that. So you can represent now, despite that this looks like a hacker website. What does is that it converts that properly to that particular domain. The funny thing is that anytime we try to copy that, right, it is being copied as this ASCII character of this puny code here, right? Now, that's great. Okay, so we look at it. It is possible for us. So, for example, if we say David, I don't know how. David Viña, because it's this. David Viña .es. All right, HTTP. David Viña. All right. So what it's gonna do is to transform into a puny code for that. Again, let's go beyond of this course, but I think this is important to understand now that why is this happening in the internal representation of that, but more importantly is that why this happened, right? And why this happened is because at the end of the day, JavaScript use now the Unicode, this encoding character set that it can be USC2 or UTF-16, all right? But right now we're using is the UTF-16 in JavaScript, which is now a 16-bit long of way of how you can, okay, it's a 16-bit long that describe all of these possible character set, okay? So what does it mean is by having this character set long, anytime or you can describe this in a Unicode as an escaping character using the U followed by 4 or 6 characters, all right? Because by default now this Unicode is only parsed as in a string, 4 of them. Anything that is go beyond is not gonna be taken. That's what we need to use is curly braces. So for example, to represent now is this character, right? So for example, this character, right? So if we say, hey, how can we know about this particular character? All right, so I want to know is what is the code point at, right? So I want to give me this, and then I want to transform this into hexadecimal to string. I can say, hey, that's one of the beautiful things of doing this, all right? Now give me this hexadecimal representation, which is what at the end of the day Unicode is using, is hexadecimal, right? And then, right, you say, okay, now that I have this Unicode, How can I now? Well, take a look at that. Well, you can say, oh, I can do is this. For, I can use escaping character and say 1F4 A9, but as you can see, it doesn't render that. And this is because this internal mechanism of escaping character Unicode that only take is the fourth length. This is part of the internal behavior of that. So to prevent this and take any take more than 4 characters, we use now the curly braces here, and well, we can now get render our or poopy emoji, right? So why this is important? Because as we understand now what this representation is, what Unicode is this character set that has, which is the umbrella terms to describe is how the computer is going to represent symbols, and has several format, USC2, or it has now UTF-16. In the case of Java, it uses now the UTS, this Unicode that is representing in this format, that start from 0 to 65,535, which is known as the basic multi-language plan. All right. So in other words, if you want to know is what is the length of that, you can actually go and access to these static methods as a way to look up the hash table that contains all of these characters and say, hey, from code point, okay, from code point, that's what it is. I want to say, hey, okay, what is the number 0 that you have assigned? And it say, well, it is this. As you can see, this is now an ASCII character, right? This is the ASCII character. So it's escaping now an ASCII character here with 00, all right? And it gives you that. You know? And it gives you this. This is what the 0 at the table represents. It's an ASCII number. And if you want to 1, and 2, and 3, and 4, and 5, and 6, and 7, and 8, you know, and then on 8 you have now the letter B, and then this another escaping character, tab, all right, and then you have now a new line, and then you have now V, and then you have 12. I don't know what the F is used, or R, and then you have now the hexadecimal character of 2 bits, right? So as you can see, then when we look at now, for example, at more than that, for example, like 65, we're starting to see that this actually represents now letters. So this is letters. That's interesting. If we go way beyond that, say 10,000, right? 10,000. Now this is starting to represent is some sort of emojis, right? You can question mark that. If we even go further than that, like 30,000, it's starting to represent now Chinese kanjis, right? If we go way than that, 5,000, right? It's now representing is Japanese kanjis and that kind of stuff. And if we go now to the limits here, to the 65,535, this perhaps doesn't render this icon maybe for some internal representation, but you know that this has, even that is empty here. Anything that go beyond this, all right, is known as the astral plane. All right, and that astral plane is made of these two adjacent 60 bits, which is known as surrogate pair. All right, where the idea here is to represent is all of these different character set beyond that basic multi-language plane. So for example, that's when our emoji like firework, it stays for. How do I know that? Because stream method allows you to have access to so from code, from, I don't know why it doesn't like that. So from code point, I mean is code point add, right? Now it's giving you is this representation, this numeric representation, that if we transform, we can indicate the index for that. But as you can see, you have now is two numbers. All right. So these two numbers, it means that if you take a look, there's no more than that. These two numbers is the representation of this symbol. So it may use these surrogate pairs. It's a combination of surrogate pairs. All right. So you have now this position of 0 and the other one. It can be a surrogate combination of characters or not. So in other words, if we do this and then we transform that into a string with hexadecimal, all right, which we get this value, and we want to escape this character using the Unicode and try to render that EF386, all right, it actually render our firework correctly, right? So, but the question is that, but what does it mean with the other one, all right? Why is that, or why is that have now this two length? Okay, why this actually show you is a two length? Well, because the internal representation of this is now using these two surrogate pairs. The thing is that by using is now this internally, because these symbols goes beyond the 65, okay, these 16-bit representations, it belongs to the astral plane, and the way that it represents that is through these two surrogate bits, so that when it's transformed to a Unicode, it now gives you these two Unicode codes, that the combination of them actually is the valid representation of them. So if you use them for separately, it doesn't mean anything. All right, we can actually try to render that, okay, and say DA3C, all right, D8-3C, and as you can see, it doesn't represent anything like that, right? But when you combine them, 86, now JavaScript understands those two Unicode as a one single, or understand these two Unicode, or understand this length, okay? Because each Unicode is known as a len, this visual representation of these symbols in JavaScript is using this 16-bit representation that each one of them is known as the length of that, this internal representation. So this is why when you combine them together, it actually gives you is the proper symbol. Now, why this is important? Because when you started to look at other emojis, for example, like this, all right, and then you ask the length, which tells you that this is 4, and you may wonder what in the F is this. So you can start to think about now the composition of these surrogate pairs. So in other words, when you do this as a way to get what is the Unicode composition, all right, or let's say you do split in this fashion, much better. If you want to know, is the composition here is made of these two surrogate pairs, right? Where when you combine this surrogate pair, actually give you is this, and I don't know why it doesn't render the dark skin tone. This actually represents a dark skin tone. That's why you have this. And also it explains now more complex elements like this. So you have now 11 length. In other words, you have now is 11 16 bits on that. So you have now 1, 2, 3, 4 surrogate pairs, but each one of them is made of course, 2 16 bits, which each 16 bit is now a length internally in JavaScript. So you have now 8 plus the white space that is using to represent this symbol, which gives you now 11. So we can actually look at the internal representation or the emojis that is being used, all right? So what is the emojis that is being used? And as you can see, is 2 women. So a woman separated by another, separated by a space, another woman separated by a space, and a man. And a man, and another man. You know, this is how internally Unicode decide to represent is this family icon, right? And I think this is polemic because a lot of people actually say, hey, but family can be more, but family can be 2 women in a relationship, yada yada yada. But we're talking about the biology, so don't get offended. If you want to submit any request, please do that with the biology, with the nature, and the Unicode team. Anyway. So here we are, okay? So here we are. So this is now explain this specific behaviors, all right? And we are known now, and we now know is what does it mean this basic multi-language plan, this astral plane, and for example, when you want to look now at the primitive behavior, string behaviors particularly, how you can have access to a string, how you can modify is the string via any funny behavior that you want to do, all right? So for example, you're trying to have access to that character and then add a new value to that. This is not the way how you assign that. Also is how do you iterate through strings using now the iterator method, which is one of the built-in method that string these internal hooks methods that string has, where you can now is iterate this using a particularly designed pattern called the iterator that I don't care about the data structure here, okay? I don't care about how this data structure is organized, whether this is a graph or a tree, or it can be another data structure, linked list, double linked list, a hash, I don't care. I just want to have a pattern, a algorithm that allow me to walk through this each independent nodes. All right. So this algorithm, which is known as the iterator, string has this internal hook known as a symbol, known symbol, which is something that we're gonna discuss later on, where we can have access to that behavior custom hook and then retrieve now each one of those elements as it is, right? So for example, like this. Again, this might go beyond the scope of today's video, but it's important at least to understand that. The other critical point is the length computation, which is something that we know how to do that, all right? Especially for emojis, but there is some cases when some letter representation, for example, the letter A in teléfono doesn't give you the same length, and to normalize that, when you need to compare that, we use now the normalization or this internationalization. This internationalization. Holy moly! This internationalization or localizations API. Why this is important? Well, anytime that you need to do is length analysis or string comparison. Most of the time is that I even put it that here. But it's exactly let me actually do this and put it this as it is. So when dealing with Unicode string that will compare or sort or do some length analysis, it's very important to keep the Unicode normalized, one. And second, if you want to do this comparison and sorting, using now, especially if you want to do that in a particular language, okay, this is true for multi-language application, which is going to become now the norm. If you don't like it, which is this normalization, as it is something that is now methods that come from, how do you call it? These now are methods or APIs that we can use to compare now letters in their own alphabet. Internationalization using the collator, which give us now is where we can specify is the alphabet and we want to compare letters there using the compare function, or the internationalization collator that allows now to get is the meaningful word. Again, it doesn't check if that word exists in the alphabet. It's just only verify that a word is greater than 2 characters, right? So anything that is that is gonna take that. So for example, we can check that out here, right? With the emoji meaningful word counter, we can say is this. It's gonna take that, or even one single character. Even one single character. This is if he wants to get now the meaningful words in a sentence. It doesn't recognize emojis, I must say. This is just a hack that I did. Using is the segmenter All right, this is useful for any text analysis that you want to do. All right, and then you want to get is the meaningful words from that. So for example, you do this, is only including is words, not symbols or funny characters and all that kind of stuff. So this might be useful for any time you want to extract now content from a div. All right, you say, hey, I got a div, but I want to get all of this, so you're going to include the div. All right, on and then you can identify is now this. Oh, so this particularly content is enclosing into a div, and so on and so forth, right? So again, this segmenter is great for doing this static analysis, this scrapping, stuff like that. All right. So yeah, absolutely. And then we look at the string comparison and the string concatenation. First, the concatenation using the plus, and the other is the string comparison using the double equal and triple equal and up that is. We're not going to explain that in this video. We just go beyond the scope of this video. And then some methods from strings. So for example, the char at, the difference is that both of them give you is the character or give you the index, all right? So give you the index, for example, A, B, C. So if you say char at, it's gonna give you is the value at that position by passing you an index. All right, the difference of the char and char at is that at accept now negative numbers, the other is the index of. All right, where instead of knowing what the index is, you want to know if that exists, if that string exists, and if it is, please give me now a number to get that, right? Right. So give me is the index where that things belong. If it's not, give me a negative number, and so on and so forth. We also look at the char code add, which give you now is the surrogate pairs, if that exists. Also the to uppercase, lowercase, to uppercase compare local, or lowercase compare. The other is the concatenation, the index of, the lax index of, which start now from the n, which is useful for right to left or left to right content, which I think is quite awesome. The other is the include and search, which is similar to the index of, but instead of giving you now the index, include going to give you a boolean, right? Whereas search is going to give you now a number, if that regular expression exists. The other is string star, padding, repeat, split. Split is something that you're going to use to say, hey, I have this string that I want to split, giving a particularly character or units. So you can do that. So for example, we have, let's say, hey, I want to split now this is by all the ones that you found here. All right, so you can say, hey, split this by 1 and give me is this sequence when now you split that, when you find a 1 and split that, right? Find a 1 and split that, find a 1 and split that. So this is good for finding is now sequence or chunks of that data, when you want to split that into this sequence of chunks. So good, awesome, completely. So yeah, this is path start, path end, start with, end with. The other is, yes, I mentioned start with and end with. Match, which is returns you the original array but in a collection. All right. So for example, it say, hey, if you found match, giving a particularly regular expression, let's say, hey, find A0, it say, hey, I found this at the first position of this. All right. So this will give you now is a collection. It will give you now a collections of all those match for this. In this case, of the first match, because match, we're gonna say that return an array-like expression matching resulting against the original object. So for example, if you say, hey, 0, 1, please return me that, the first you encounter, all right, as well as the index that you make that first encounter, or this, all right, or this. So it's gonna tell you now the index where it's found and the input as well, right? And if it found any other groups that matter that. So this is great because match is gonna give you is where it found that, not as we might expect. So match, and you got it. So match here retrieves the result of matching the string against a regular expression, right? So whether it's we pass now is if we pass in a string, it will now return you is the first occurrence, all right? If you pass now a regular expression, which is something that we were doing, or let's going to do that. So regular expression start with this. Regular expression start with this and say, hey, any time that you found now this, and I want you to give me that. For any digit that you found here, like this. I'm not quite familiar with this match. Yes, it is interesting. Also, match has its own known symbols. Give me a second. And we're back. And we are back. All right. Perfect. So now it's using that. That's interesting. Symbol.match. If an object has a symbol match method, it can be used as a custom match. The return value of symbol match becomes the return value of match. All right. Again, symbol, as I mentioned before, they were being used as a these no-well symbols are used as a way to have access to these custom hooks that some specific behaviors owns. All right. A non-regular expression as a parameter as well. And that's interesting. There is a typo here. Yeah, there is a typo here. Oh no, that's not a typo. That's actually is. No, it works. It works. That's interesting. Good. So match a number is a string, returns a number. So you have also some of the corner cases of the match, which is minus infinite or infinite, 65. Return 65. Giving that string here. My grandfather is 65, old. And again, it returns you the first instance of that. It returns you the first instance of that match. All right. For regular expression, well, it's gonna give you is those that actually match here. Right. If you pass in a string, it's gonna give you only one, the first match. If you pass a regular expression, it's gonna give you all that match. It's a collections of all that match. All right. If it's not, does not. But that's interesting in terms of the match here, right? So a lot of people might use is, hey, is this value that I'm receiving, so it match, right, with some regular expressions. You have to be careful with that, especially if you're gonna use that as your interview. You'll prefer to go with includes, right? You'll be much safer than that. A or T, right? It'll be much better for you. It also do a linear search. So include and search, you have to be careful when to use that. I'll prefer to go with include to get this Boolean value. All right. Then we look at the match, the replace, which is helpful, very helpful. Which say, hey, I want to replace, if I have now 0, 0, 0, 1, 1, or a long string that say Lorem ipsum Dolores. Okay, this is come from the the design as a way to fill some text. All right, Lorem ipsum Dolores. With here you say, hey, I want to replace, all right, I want to replace is this, okay, I want to replace is this value, all right, any O, I want you to replace with this particularly value, right? Of one or more matching occurring in the specified regular expression. That's interesting. Again, when you pass in a string, it only replaces the first one. all right, is only replaced is the first one. However, if you pass now a regular expression, and if you say, hey, find any O letter, all right, and replace that with E, I am not sure how you can say in a regular expression that Ruby regex or regex expressions, all right. This one. This is this side, all right. Let's say I want to include is only the O's and O, and O, or only O. This is a special character. That's interesting how this website is maintained, bro. Regular reference, character class. Exactly, it's a character set. It's a range. Match any or match a word. Match any. Okay, match any. Okay, match any. Here, there you got it. So we want to say, hey, match any. All right. Match any here, any character here, and replace that with the letter I, you know. Syntax error. Invalid unexpected token. And which? Okay. Or I can say is exactly, this is how you create this. Okay, so this is how you create this. Come on. This is how you create this regular expression, right? And then here you say, well, give me only those that match O. So anytime that you find an O for each instance, or match any, all right? So match any, and I want you to replace that with I, right? And here it's gonna find now all of this. If you don't pass that, a regular expression is just going to find the first, and that's it, right? It's important to understand this subtle difference because when you're going to develop or when something is asked for, you might need, it is quite helpful for you to understand what it's doing here. So things like replace and search is gonna find for the first letter that it is found or a regular expression that match here, okay? So that's why I prefer to go with include, depending on the use case, or with another one, all right? Now, this is good This is great. All right. Um, and then we look now at the methods that we describe, the static string helpers, which is how you can have access to this hash table for from code points, and the escaping characters. Escaping characters like, for example, break a line, a new line or a character. There are some escaping characters that I'm not quite familiar with, right? So for example, I know what is this, all right? I know what is this. So if I try to escape this character, this is a, so you say this, hey, and then you try to use this escaping character, all right? Is this one? Oh, this is if you want to escape some character here? Okay. But I don't think so. DB, DF. I'm not sure what the F does. Or N, or or T. I know tap. I know what taps does. Alright, this is for a... Let me actually look at that. You know? Because there's some string characters, some escaping characters that I know what I'm doing. Escape sequence. And you don't know. You don't know JavaScript. Oh my god, for real? Wow, that got a bad CEO. Okay. Okay. Alright. There you got it. No, it's with escaping character here. Escaping characters. So, followed by one or more characters that JavaScript recognize and parse with special meaning. Any other character in a string that don't parse as an escape sequence, single character or multi-character, are inserted as is into the string. For single character escape, the following characters are recognized after this: B, F, N, R, T, V, O, comma. For example, ends means new line, tab means new tab, etc. If a slash is followed by any other character except X or U, explained below, like the K, that sequence is interpreted as the K being an unnecessary escape, which is drop, leaving just the literal character itself, K. So for example, in there, for single character escape, the following characters are recognized after that. To include a quote in the middle of this, delimited the string with this escape sequence. Okay, so for example, if you want to use now an escape sequence, for example, like this quote, and let's say you do is this, all right? So I want to now escape this sequence and say hello. Arthur because I need to escape that again. I need to escape that. Again, that's interesting. So anytime that I want to escape this particular character or the another one, I need to use this escape character. There are other escaping characters that are now escaping. Okay, in the text / is most common, but occasionally you will need a backslash to include a literal. Especially if you want to do this. If you want to include another backlash. Okay. To include a literal backslash character without it performing as a star, as a character escape sequence, use double backslashes. So then what triple backslashes string parse as? The first two should be an escape character, thereby inserting just a single character as a string value, and the remaining will just escape whatever characters comes after it. And so on and so forth. One place backslash show up commonly is in window file path, which uses single separator instead of that. That's interesting, because if I do this and then I store that into a variable, let's say name, and then I console log that name, I get that single. I get that single. Okay. Here we go, bro, fellas. I get that single, bro. Exactly. I get that single here. To escape characters. And the other is to escape now // here. Exactly. To escape a single, use double. Exactly. Use double that. Interesting. Very, very interesting. The other is a line continuation. What about your both 4 backslashes in strings literal? Well, that's just 2 escape sequence next to each other, so it results in the 2 adjacent backlashes. In the underlying string, you might recognize there is an odd and even rule pattern at play. You should thus be able to decipher any odd or even number of backlashes in a string literal. If you have odd, if you have even, it will give you is, well, the half of that. If you have odd, it will not parse that. But if you have odd, exactly, it's expecting another character sequence. That's what happened. If you have an odd sequence, it will expect now an odd sequence, an escaping sequence here. That's interesting, especially in JavaScript. Line continuation. Then you get is this last character followed by actual new line character, not just literal N. It's a special case, and it creates what's called line continuation. As you can see, the new line at the end of the greeting is immediately preceded by a slash, which allows this string literal to continue onto the subsequent line without escaping slash before it. A new line, the actual new line, not the new character escape sequence, appear in on. Exactly, this is line continuation. So if you want to now add some text and say, hey, hello, you do this. Come on. Hello. What up? Hello, ¿qué tal? ¿Qué tal? All right. Okay, now it parsed. Hello, ¿qué tal? You know, line continuation for this. What it refers to multiple string. There is no need to use this because now we can use this template string. So multi-character escape. We look that we can use is now the ASCII as well as Unicode in a string, and how you can now escape is bigger Unicodes, right? Especially using the curly braces. All right, as well as the Unicode normalization. Anytime that, yes, this is now escaping sequence. So escaping sequence is helpful when you want to, for example, is, hey, we want to print this single or double quotes, all right? Or a forward slash, not a backslash, okay? So it's quite interesting to understand that. The other is the multi-character escape, whether it's ASCII, using the hexadecimal and followed by 2 digits, or the Unicode followed by 4 digits. But if you want to now escape now Unicode characters more than that, you use a curly braces. And anytime you're going to now evaluate Unicode, it's important to normalize them. Anytime you're gonna sort or compare, or where the length analysis is important, it's preferred for you to use the normalization form of that. So that's very interesting because that conclude is the entire aspect of the string, which is huge, all right? But once you get familiar with it, it's pretty straightforward. Now, finally to what we really care in today's video after 1.5 hours, which is numbers. So to make it short, because number is another word in it itself, all right? And to make it short here, numbers here in JavaScript are represent in a numerical, in whole, as a whole number or as a decimal, right? So because of this is using now the 16-bit representation, which is known as the double precision binary point decimal values from the IEEE 74 spec, which describe how now this double precision binary point values, aka 64 bits, is now represented. So the entire 64 is not represented. In fact, is from 0 to 52 bits that is used to represent now the value known as the mantissa, the fraction. The other 11 elements, or 11 elements is from the exponent, and the other is from the sign. The idea of this is that the more the idea here is to understand that when you are now going to detect if this is an integer number or not, no matter how decimal point it has, all of them 0, is going to be converted into a whole number. the parsing and coercion thing is important because parsing is how this number is going to be converted, all right, or it's going to be used, whether it's an when you have a string, where as long as each one of those string or characters are a valid representation of a number, if the first dot that it encounter parse int, it will now stop evaluating. It will not include is also a scientific notations. This is when now parse float comes handy, all right. And some of the coercion, which is another word, is how you're going to deal when you receive now a string here. And not only for a string, but also for other types of data, all right? So for example, how do you translate now, or primitive, how you parse is now undefined. It parse that to 0. How do you parse now null to 0? How do you parse now boolean? 0. How do you parse now empty string? 0. In how do you parse now is objects, my friend, okay, such as an empty array, an empty array, exactly. So it parses that as empty string. I mean, it's 0 here. It parses as 0. How do you parse that now when you pass null to it? As 0. When you pass undefined, as 0, right? Good. But if I pass you now undefined, how do you gonna parse that? As not a number. And if you pass now null as 0, so the behavior is not consistent. All right. Holy moly. What if I pass you now an object? Well, it's gonna give you now another number, which is good. Thanks. What if I pass you now is a collections of values? This is not a number. That's right. So if I pass you now a string, all right, which holds a number, would you do that? Not at all. So this particularly corner case when coercing a value, and also if you're gonna pass now a big int, it's gonna coerce that. Well, no, they're not. It's gonna coerce that into a number, but as long as that is in the range of a safe integer. And here is when we need to understand if what does it mean a safe integer, because we can also use some other representations, yada yada yada, and why this is important to for example, we can also use this lowercase, helpful for readability, and why this is important to understand the IEEE 754 bitwise binary representation. Well, because at the end of the day, the idea of this, all right, is that the more bigger the integer part is, the less space you have to represent no decimal, and vice versa. This is the entire TLDR of this IEEE 754, right? Is that it now have some limits to represent that, all right? And the limits, because do the 15 bits representation of that, the whole number portion and the decimal portion, right? Because of this, now we have is a maximum number that we can represent accurately. This accuracy is something that we're going to look at it, because that's what is the today's video. To explore and to look at it. Explain template literals, that's right. Number values, and here we are, parsing and coursing, all the numeric representations, and the IEEE 74 bitwise binary representations. We also take now the TLDR of all of this is that, but understanding now how that works, all right, as might be evident now that we have seen how the IEEE 754 works, all right, the 52 bits of the number base must be shared, representing both. So that mantissa, that 52 bit representations must be shared between the whole number, the whole portion, and the decimal portion, if any. Essentially, as I mentioned before, any large numbers, okay, any large numbers with a whole part, so the larger the whole number portion is, the less bit are for the decimal. Again, why is this? Because the way, how do we store now bit in our computer? Because our memory is limited and we cannot represent all the number that we want, all right? That's why we have, right now is this 16-fold bit representation or double precision, aka is this the 32, since 32 is the precision level, is the level of precision. So 64 is known as a double precision because it's twice the 32. You can also find another computers that holds even further than that, like 256 precisions, where allow you to, of course, represent this huge number. But here in JavaScript, on the web, all right, the max value of that is so the largest value that can be accurately stored in the number type is exposed by that. Where this value come from? All right, that's a good question. Where the particular value come from? You might expect the value to be a decimal value, given the representation, but on a closer inspect, E38 is approximately 2 power of 20,000. Okay, 2 power. That seems much more like it should be an integer, right? We can verify that this, okay, still an integer. But again, this representing is a 2. So if you transform that, you say, hey, number to max value, all right, and I get this, and I want to stringify this or coerce this value to this, and then I want to, what do you want to do that? Because I want to transform into a binary representation. That's what I'm doing this. To string as a binary, all right, it tells me that, hey, I cannot represent that to this. Okay, no problemo, amigo. I thought you will be able to. To string, to precision, to fixed, to local, to exponential. All right. Well, if I want to transform that into 2, into a binary, you get is this. But what happens if we go above the max value? It's still true. All right. So the 52 bits of the number base must be shared, representing both the whole number and the partial number. So this is the maximum integer value that we can represent. This is important to know. The maximum integer value that we can represent. Okay. Is this. This is the largest value that we can accurately store is this. Alright? But what about if we want to now that is integer plus 1000. Is this still a number? I mean, it's integer. It's going to give you true. And if you want to compare that to this, to say, hey, is this still the same as max value? I mean, is this it tells you that this is still true, and not to mention more than that. So is not max value actually is the largest value representable in JavaScript. It is certainly the largest finite number value. ES defines a special infinite value which JavaScript exposes as infinite. There is also a minus infinite as a far another end of the number line. Value can be tested to see if they are finite or infinite. You can ever count over with +1 to the number max value to infinite, no matter how long you let the program run, because the plus operation 1 isn't actually incrementing beyond the top number max value. However, JavaScript arithmetic operation plus multiplication and divide can definitely overflow the number to the type of the top end, in which case infinite is resolved. Exactly. So you can, of course, do that. The reverse is not true. An arithmetic operation of an infinite value will not produce a finite value. Interesting. Exactly. An arithmetic operation of an infinite value will not produce a finite value. Okay? So, for example, you want to say infinite minus 1e to 22,091 is gonna give you now infinite. Alright? So, why we are mentioning this? That's a good question. Why we are mentioning this? Why we are mentioning this? How can I remove this? Okay, I want to remove this table here. So why do we even care about this? Going from the very large to the very, very small, actually closest to 0, which is not the same going very, very negative. the smallest absolute decimal value could theoretically store in the number type will be 2 power of this. Remember, the IEEE exponent range, or around EX308. However, however, JavaScript engines are allowed by the specifications to vary in their internal representation for this lower limit. Whatever the ng effective lower limit is, it will be exposed as the mean value. Oh, this is the mean value. Now, in this case, number. This is the lower based on the JavaScript engine implementation here. Usually this. So in other words, this is the negative portion that you can represent here. Okay. If I say 5, 8, 10, is this one exactly? It's multiplied by 10. That. All right. So you have now 324 leading zeros, or no, is you have now trailing zeros negative. All right, in this range. Okay, in this range here. Okay, makes sense. Okay, cool, interesting. Okay, so going from very, very large, which is max value, all right, that's interesting. This is the maximum value that you can represent in JavaScript in a safe way, and the other is the mean value that you can represent in JavaScript is this. So whether it's maximum value that is 1.79 with 308 trailing digits, exactly trailing digits, or with the other one? Jesus. Yeah, with the trailing digits, 308 trailing digits, or you can have now 324 trailing digits, but in the negative space. Oh my God. That's interesting. That's very, very, very interesting. Okay. Most JavaScript engines seems to have a minimum representation value around this, which is like this. Depending on the engine and the platform, a different value may be exposed. Be careful about any programming logic that rely on such implementations dependent values. So we describe here is the number limits. And why do we even care about the number digits? Okay, the number limits, especially if you're gonna work with finance applications or scientific applications and so on and so forth, right? So, which is in my case, I'm about to work for a bank here, particularly bank here in Argentina, to help them improve their user experience on the web with building Designing and building and deploy is a user interface. This is also the reason why I'm actually looking at this, to actually understand this particular language, especially JavaScript. And now we get this this max value and lower value as it is, where now the number mean value is usually this. All right. So in other words, the max value is 2 powers 20 is here exactly. So the max value here it doesn't tell me here. So the max value here is this. Infinite. And then it becomes now 0. And then now it becomes now infinite. You know? But it's roughly this. This is the maximum value that you can represent. And approximately, exactly, approximately is this minus 1. Okay, so the max and mean values, so so max value approximately is this. All right. And the mean value is this. And the mean value approximately is this. So you can use this as a way to represent that. It's going to give you now the representation of this. And if you add another number here, is now interesting. Is now give you 0 here. Anything bigger in the negative sense than that, or any smaller number in that, and is gonna give you this. So the safe integers here, since number max value is an integer, you might assume that is the largest integers in the language, but that's not really accurate. The largest integer that you can accurately store is type this, which is way smaller than the max value, which is about this. This especially safer value is exposed as number safe integer. That's interesting. We have seen that integers larger than this can show up. However, those larger integers are not safe in that the precision, accuracy start to break down when you do operations with them. In other words, because the way how it's now stored, how they represent, as shown above, the max 1 plus 1 and max 1 2 expressions both errantly give the same result, illustrating the hassle with exceeding the number of max safe integer limit. But what's the smaller safe integers? Depending on how you interpret smaller, you could either answer 0 or number.MindSafe integer. In JavaScript, provide utility to determine if a value is an integer in this safe range. So anytime we talk about now accuracy or precision, and when we talk about now precision, so for example like this, and look at this, that you have now 0.333333, but again this number is not accurate in its precision, so you cannot accurately represent is this number pretty much like this, you know, where that ends there. And because of this representation misbehavior, because of this representation, all right, because of this representation of those numbers, we cannot accurately represent them as it is. Illustrating the hassle with exceeding the number of max safe integer. So, but what's the smallest safe integers? Is this. And JavaScript provides that. That's interesting. So safe integers. Safe integers. So safe integers. Right? Safe integers limits. So you might think that that's the largest integer that the language can represent. But that's not accurate. The largest integer can accurately store numbers into this. The largest interest exactly. So the largest integers can accurately store the number here. So the largest integer can only store number up to this and to the mantissa bits accurately. All right. And by I mean accurately is that when you do some operations on that, things go fucked up. Which is way smaller than number value that what we expected. All right. So a good example of this. So a good example of this is this. So a good example of this. So let's go into now assume here and say, hey, what's the max integer here, right? So the max integer here is number dot max safe integer. All right, we store that. That's right. It's the same to 2 power 53, which makes sense. So if you, for example, all right, increment that plus 1, so it does that accurately. But if you do that max in plus 2, what? Because of this, all right, because JavaScript cannot accurately represent, because JavaScript cannot accurately represents numbers greater than the safe integer limits, okay? Because JavaScript cannot accurately represent numbers greater than the safe integer limits when doing operations, when doing arithmetic, that's right, arithmetic operations, okay? Yep, when doing this arithmetic operations, this is the reason of why we have seen the integers larger than it can show up. However, those larger integers are not safe in the precision accuracy start to break down when you do operations. So in other words, because JavaScript cannot accurately represent numbers greater than the safe integers limit when doing arithmetic operations, since the precision breaks down, all right, this is this explain why 0.1 plus 0.2 is equal to 0.3 for that, right? The other is the double zeros, something that that we must be aware of this as a programmer, since it happens in any programming language that use that representation, that use EEE 754 number representation spec. That's interesting. Very, very interesting. Now you got double zeros here. It might surprise you to learn that JavaScript has two zeros, positive and negative zeros, but when on Earth is a negative zero. Signed zeros. Yeah, but when on Earth is signed zeros, double zeros. A mathematician will surely balk at such notion. This isn't just a funny GS quirk. It is a mandatory by IEEE 754 specification. All floating points number are signed, including zero. and thought GS does kind of hide the existence of negative, it is entirely possible to produce and detect it. Exactly. So you may wonder why we have ever need such a thing as -0. It can be useful when using numbers to represent mode, the magnitude and movement, or some item like game changer characters or an animation, and also the direction here. So anything that you want to represent is speed or movement, directions of some items like a game characters or an animation. This is it. Without having assigned zero value, you couldn't tell which direction such an item was pointing at the moment it comes to rest. While JavaScript defines a sign 0 in the number type, there is no corresponding sign 0 in the big int number type. As such, -0 is just interpreted as 0, and the two indistinguishable. So this is known as a double zero, all right? Double zeros, or aka the positive and negative zeros, okay? Positive and negative zero. This is something that it is mandated by the IEEE. This isn't just a funny GS quirk. It is a mandate from. This isn't just funny as GS quirk. It is mandated by the IEEE 754 for that. All floating points number are signed, including 0. And though JavaScript does kind of hide the existence of -0, it is entirely possible to produce it and detect it. So for example, if you want to detect now if a -0, this is the specific functions for that. All right. And also you can use the object that is to detect that. -0. Regular 0. Exactly. Exactly. Because they are known examples here. So you may wonder, why do you need it? Can be useful to detect is movement here. That's one of the reasons why I'm gonna put this. It can be useful when to detect movement or speed in animations. That's what we're looking here. So you can use that only on numbers, not on big int. Then you have now the invalid number. Okay, mathematical operation can sometimes produce an invalid result. So for example, if you now divide here, and in this case actually is now an arithmetic operation is preferred, well, this is it. It's probably obvious if you try to divide a number by a string that is an invalid mathematical operations. So the historical root of NaN from the IEEE 754 specification is an acronym for not a number. Technically, there are about 9 quadrillion values in the 64 bits number space designated as NaN. But JavaScript treats all of them indistinguishably as single NaN value. Unfortunately, that's not a number, meaning producing confusion with NaN, since NaN is absolutely a number. That's one of the reasons here. Why NaN is a number? So, the historical root of NaN from here, the specification, is an acronym for not a number. Technically, there are 9 quadrillion values in the 64-bit, right? There are about 9 quadrillion values in the 64 bits IEEE 754 number space designated as NaN. But JavaScript treats, okay, there are about 9 quadrillion values in the 64 bits number space designated as NaN. But JavaScript treats all of them indistinguishably as a single, not a number value. Unfortunately, that's not a number, meaning produce confusion, since NaN is absolute a number. You can prefer to this exactly. So invalid number or NaN, but I prefer to use not a valid representation of a number that is a number. Exactly. So mathematical operations are going to produce that. It's probably obvious, but if you try to divide but it's this. Why NaN? Why is NaN a number? Think of the opposite. What if a mathematical okay? What if a mathematical because invalid number is a way to represent that a mathematical operation produces an invalid number. Think of the opposite. How you represent, or what if a mathematical numeric operation like this produces a non-number, okay, value, like null or undefined, etc. Wouldn't be that really strange and unexpected? If you try to produce something that is not this, well, if you threw now a null or undefined, well, they don't represent that, so yeah, no, okay. What if they threw exceptions, so that you had to try and catch all your math? Holy fuck. The only sensible behavior is that numeric mathematical operation should always produce a number, even if that value is invalid because from an invalid operation. So to avoid such confusion, I strongly prefer to define not as not an applicable number, not a representation number, or not a valid not a valid representation of a number, not actual number, not available number, not applicable number. I prefer to use is that non-valid representation of a number. NaN is a special value in JavaScript, is that is the only value in the language that lacks of identity property. It lacks of identity property. It is never equal to itself. So unfortunately, the triple operator cannot check a value to see if it is a NaN. But there's some ways to do this, and that is through the object.is. So number is NaN, or NaN.include politician IQ. If this not nothing, politician IQ is nothing, it's divided by infinite. You think you're funny, right? It's because you don't know how to deal with the human nature, man. Here's a fact of virtually all GS programs. When you realize it or not, NaN happens seriously almost all programs that do any math or numeric conversion as subject to NaN showing up. If you're not properly checking for NaN in your programs where you do math or numeric conversion, you can say with some degree of certainty you probably have a number bug in your program somewhere, and it just hasn't beaten you yet that you know of. JavaScript originally provided a global function called is NaN for NaN checking, but unfortunately it has a long-standing coercion bug. Exactly. So in other words, use the number is NaN, but you should never be used. When NaN checking, always use number.is NaN or object.is, etc. Exactly. When NaN checking, always use the number is, and there you got it. Holy moly, bro. But that makes a lot of sense in the invalid here. Okay? NaN is a special value that is the only value that is lack of property here. And if you think about this, why NaN is a number, right? So you say tip. Why NaN is a number? So if you think about the opposite, you get that as it is, right? Okay, so if you want to check now, so when NaN checking, use this. Okay. when checking NaN, which is this, when checking NaN, always use the number that is, and number is NaN. This politician IQ, I love it. politician IQ is equal to nothing divide by infinite. Infinity, right? So you get another number. Really? So any mathematical operations that produce a non-valid number, okay, are not a numeric representation, not a valid numeric representation of a number, it's gonna give you that. And if you want to check that, all right, you either use the number that is NaN, all right, between NaN, between the politician IQ, all right, which is give you now that this particular value here is not a number, or you can use the object that is that I prefer to use to compare that. Object that is to say NaN and the politician, if you want to compare NaN and the politician IQ, right? And it gives you true. All right. So then we reach now at the big integers. But before moving into that, all right, which is something that I prefer to do that later, I want to now move on to the number behaviors. All right, the numeric behaviors, string concatenation, string values, static, and here we are, numbers behaviors. All right, so this number behavior. There you get it. The number. Exactly. Now you got is the number behavior. All right. So the number and the number behavior. Similar with string behavior. Exactly. String values and the string behaviors, bro. String values and the string behaviors. So this string values and the string behaviors, and then when we reach to number is the number and the number behavior. All right, let's get into this. All right, floating point imprecision. Okay, which is something that we are already quite familiar with. This is not uniquely to GSX. Okay, numbers are used for a variety of tasks in our program, but mostly for mathematical computation. Pay close attention to how JavaScript numbers behave to ensure the outcomes are expected. This is for floating point imprecision. We need to revisit our discussion about this. All right. One of the classic gotchas of any IEEE 7054 number system in any programming language is that not all operations and value can fit nearly into this representation. So you cannot accurately represent number there. But the respective bit representations are this and this. So if you look closely at those bit patterns, only the last two bits differ from 00 to 01. But that's enough for those to be unequal. Again, just to reinforce, this behavior is not in any way unique to JavaScript. This is exactly how any IEEE 7054 conforming programming language will work with the same scenario. As I assert above, the majority of the programming language use that, therefore they're gonna suffer the same fate. The templation to make fun of JavaScript for 0.1 plus 0.2 is different to 0.3 is strong. I know, but it is completely bogus. Pretty much all programmers need to be aware of the IEEE and make sure that they are careful about this kind of gotchas. It is somewhat amazing in a disappointment when how few of them have any idea of how IEEE 7050 works. If you've taken your time reading and understanding this concept so far, you are now in that rare tiny percentage who actually put in the effort to understand the number in their programs. And it's because at the end of the day, you're going to use any tool you need to learn about, you need to know that. Now, epsilon threshold. A common piece of advice to works around such floating point imprecisions use this very small number value defined by GS. But if that, okay, epsilon is the smallest difference JavaScript can represent between 1 and the next value greater than 1. And the next value greater than 1. While this value is technically implementation platform dependent, it is generally about 2.2e minus 16. Okay. Oh, holy fuck. It's okay. Epsilon is the smallest difference JavaScript can represent between the 1 and the next value greater than 1. To those not paying close enough attention to the detail here, including my past self, it is generally assumed that any skew in floating point precision from a single operation should never be greater than number.epsilon. Any skew in floating point precision from a single operation should never be greater than the number.epsilon. It can never be greater than this smallest difference that can represent between 1 and the next value greater than 1. Thus, in theory, we can use number.epsilon as a very small tolerance value to ensure number equality comparison are safe. Number equality comparison are safe. Safe numbers are equal. Number equality between 1 and the next value greater than 1. In this first edition typogram book, indeed, I recommend exactly this approach. I was wrong. I should have researched the topic more closely. But it turns out this approach isn't safe at all. Okay, if you do 10.1 plus 0.2, okay, and then it's telling you that, okay, 10.1 plus 0.2, anytime that you're doing this mathematical operation that doesn't give you now an accurate number, okay, is not equal to 10.3. Of course, safe numbers equal 0.3 AB and 0.3. So this false. Well, that's a boomer. Unfortunately, number epsilon only works as a safe equal error threshold for certain small number operation, and in other case it is far too small and yield false negative. You could scale the number.epsilon by some factor to produce a large threshold that avoid false negative, but still filters out of the floating point skew in your programs. But what factor do you use entirely to manual judgment call based on what magnitude of values and operation of them your program will entail? There is no automatic way to compute a reliable universal threshold. Unless you really know what you're doing, you should not use number.epsilon threshold approach at all. If you like to read more of the details and solid advice of this topic, I highly recommend reading this book. But if we can use number.epsilon to avoid the peril of floating points skew, what do we do? If we can avoid floating points altogether by scaling all your number up so they are all whole numbers, integers, or big ends, while performing maths, do so. Only deal with decimal values when you have to output represent a final value after all the math is done. So for example, if you do something like, hey, I want to represent this number, this is 1 million, all right? Unfortunately, this won't work. Okay. So represent all your numbers. That's pretty fucked up. So represents all of your numbers, okay? Only deal with decimal values when you have the output represent a final value after all the math is done. If that is not possible or practical, use arbitrary precision decimal libraries and avoid numbers value entirely. Or do your math in another external programming environment that is not based on IEEE 754. So if you can avoid floating points altogether by scaling all of your numbers up so there are whole numbers, integers, or bit int, while performing math, do so. Only deal with decimal values when you have output represent a final value after all the math is done. Okay. Epsilon threshold. Okay, floating point imprecision, epsilon threshold, and the numeric comparison. Okay, so here we look at the floating point imprecision, floating point imprecision. Okay, which is the 0.1 plus 0.2, all right, and the epsilon imprecision oh sorry Jesus, imprecision, and the epsilon imprecision. TL didn't read, use or scale your numbers to scale your numbers to scale your dig. If you have, no, it's not here. So, but if we can use the number.epsilon to avoid the peril of floating point skew, what do we do? If you can avoid floating points altogether by scaling all of your number up, so they're all whole numbers, integers. Exactly. If you can avoid floating points altogether by scaling all of your numbers up, so they are all whole numbers or big ints, while performing maths, do so. Exactly. If you can avoid, because it's this, if you can avoid floating points, by scaling all of your number up, so they're all whole numbers, integers. If you can avoid floating points number by scaling all of them up to integers or to whole numbers, exactly, to whole numbers or big int, while performing math, do so. While performing math, do so. I think this is another interesting question to ask. To ask them. How do we handling is the precision here, the point floating numbers here, numeric comparison. In mathematical operations. Somewhat surprisingly then, increment and decrement, all right. And the other is the bitwise operator. And number values method. All right, so that'll be all for this video. All right, that'll be all for this video. Take care. Bye bye.